Hey kids, this is your video on section 8.2, zero and negative exponents. Our disclaimer as usual is that this is not a perfect replacement for attendance in class or attentiveness in class. This isn't the exact lesson that we have, it's just the high points. There's other ways of teaching this, probably better ways of teaching this, but this is what we're going to use for now. For those who maybe missed a lesson, maybe need a refresher or some homework help. So when we were learning about negative and zero exponents, we were using what we know to go into what we don't know, and also using some number patterns. So here I have 10 squared, which we know is the same as 100. 10 to the power of 1 is an actual expression, technically. We wouldn't write a number, a base number, to a power of 1. We'd typically just drop that 1, but 10 to the power of 1 would be 10. Now, following that number pattern, what would 10 to the power of 0 be? If you said 0, you were like most people, but it is not 0, it is 1. In fact, any number to the power of 0 is 1. And that makes sense because if I were to look at each step moving up, I am multiplying by a power of 10. Makes sense because I have a base 10 and I'm increasing my power by 1 each time. Now we can do backwards, divide by 10, divide by 10. So 10 to the power of negative 1, 1 divided by 10, it's a fraction 1 over 10. Some people think that a number, a base number with a negative exponent will be a negative number. It's not, it's going to be a decimal. And if I divide by 10 again, 1 over 100. Okay. Now, is there an easier way to find this without having to make this big table to figure this out? Yes, there is. There are a couple rules that I'd like to teach you. One is this. Any number to a negative exponent is the same value as 1 over, the numerator will always be 1, over that same expression, only we're losing this negative here. So let's say, for example, I have 2 to the negative third power. That means the same thing as 1 over 2 cubed, or 1/8. Those all mean the same thing. So that's like moving from here to here. Well, we can do the opposite of that too. If I have a fraction where I have a base number to a negative exponent in the denominator, we can flip that back up into the numerator and lose the negative on the exponent. So let's say, for example, if I had 1 over 2 to the negative third to start with. Well, that means the same thing as 2 cubed, or 8. All right. Now, the reason why we care about negative exponents is this. Just like, it's kind of an analogy to show you, if you were doing a math problem and you got 2/4 as a solution, that would be kind of weird because we are in the habit of simplifying our fractions to the lowest form. Well, that's the same as negative exponents. You'll eventually get far enough in math where you'll see a base with a negative exponent and you'll be like, I should probably write that with a positive exponent. Or if the expression with a positive exponent is something like 2 cubed, which is 8, we would tend to write it like this. It's more practical to say 1/8 than it would be to say 1 over 2 to the third. This makes more sense to us in a practical sense. So now let's do some examples. We'll start easy. We'll get more difficult. If you'd like, you can pause this and attempt to do as many of these as you can and then hit play again and I can explain them, or you can just watch the whole thing and see if you can follow along and then try yours on your own. You do whatever you want, but I am going to just assume that you're going to play or replay or pause or whatever you do as needed, and I'll just provide the explanation if that's okay. All right, so 3 to the negative 4th power, if you use this, is the same thing as 1 over 3 to the 4th power, which 3 to the 4th power is 81. 1 over 81. And that's the final solution. And that's it. For the next one, if you remember from last section 8.1, if I have a negative 2 on the outside of the parentheses, that means the same thing as 5 to the negative 2nd power, a to the negative 2nd power. And to write these using a positive exponent, I could say 1 over 5 squared times 1 over a squared. Well, 5 squared is 25, so I can say 1 over 25 times 1 over a squared. Keep simplifying. 1 times 1 is 1. 25 times a squared is 1 over 25a squared. Now, there's another way that you could do this, and we're at the point in our math where you can solve these using a variety of processes, and none of them are necessarily worse than others. Some are more efficient, though, for sure. You could instead say 1 over 5a squared. You're putting this whole expression in the denominator. The only thing we're changing is the negative on the exponent. And so that's the same as 1 over 5 squared a squared, 1 over 25a squared. Same solution, just a little bit less work. Okay, same for this one. There's a couple different ways that occurred to me that you could do this. Here I have the same base, no parentheses, so if I want to combine them, I'm going to add the exponents. So negative 2 and 2 are 0. Anything to the power of 0 is 1. Now if you do it that way, that's pretty quick and easy for you. There is a longer way that you can do this. 3 to the negative second power would be 1 over 3 squared times, keep that 3 squared. 1 over 3 squared is the same as 1 over 9 times, oopsie, that's a times, times 9. 1 times 9 is 9. 9 times 1 is 9. 9 over 9 is 1. We get the same answer. This is just a little bit more tedious than the other. Okay. Okay. Same for this one. You could do 1 over 2 to the negative third squared. When I put this expression in the denominator, I lose the negative on the outside exponent only, not both. That's kind of a subtle rule here. And so now I can multiply 2 times negative 3 to get negative 6, and then flip it back up to the numerator, and then 2 to the power of 6 is 64. That's very complicated and hard to follow. To make it easier for you, you could just say negative 3 times negative 2 is positive 6. 2 to the 6th power, and 2 to the 6th power is 64. Same answer, just a different way to do it. Okay, here is another somewhat tricky one here. We have 5 times whatever 2 to the negative x is. And that means 5 times whatever 2 to the negative x is, which we can write like so. And so 5 times 1 is 5 over 2x. Now, we are going to keep it like this. We do not simplify it into 2.5 to the x power. We can't do that because this exponent is on the 2, not necessarily on the 5. So this is our final answer. I know that feels kind of weird because this is an improper fraction, but we're going to keep it just like that. All right, this is the big one, the ultimate challenge for you. I hope you got it. This 2 has a positive exponent of 1. We don't write that 1. I'm just going to keep it just how it is. Times 1 over x squared times 1 over y squared, cubed, sorry. If we multiply across, 2 times 1 times 1 is 2, x squared, y cubed. And that is that whole expression. Now, if you study this and this, is there a shortcut that you could take? Yes, there is. So you'll notice that the 2 stayed in the numerator where it was. The 2 was the positive. The x and the y both flipped to the denominator, and they lost their negative exponents. So the shortcut is if a base has a negative exponent and it's in the numerator, you can then just put it in the denominator with a positive exponent. Or if it's starting in the denominator with a negative exponent, you can just flip it up to the numerator with a positive exponent. A couple things to notice as to note while you're doing your work. Please, knowing what we are doing in the next few sections, I need to advise you to please write your fractions with a horizontal bar. So write your fractions like this, not like that. That will set you up for success in the future, so you can read things and follow things a lot easier. And also when you're doing your work on lined paper, don't try to squeeze your fraction like this. Split it up between two lines, because as we go, your numerator and your denominator are going to have exponents. And so it's kind of like having 4 levels. And if you try to do that all on one, your exponents start to look like the base numbers, and it's very confusing. So, pro tip for you if you care. I'm looking out for you guys, wanting the best for you. All right, so we did some homework for this. Looks like this. Try to simplify it for you. This used to be a lot bigger, but I figured 20 questions was enough. And so basically you're just going to simplify all these things, writing all of your exponents positively. Couple things to remind you of. Anything to the power of 0 is 1. Also, if things get overwhelming, multiple pieces of these questions, I advise you to split them up into smaller parts. Take it a section at a time, show all your work, make sure it's lined up, organized, linear, and that will help you a lot. So this is side A. I can help you with some example questions for side B, so that you don't have any troubles. Okay? All right, so let's find a couple up here. So, ooh, out of focus. Still out of focus. Wow, that's really great. One more time. Come on, buddy. Okay, great. Okay, so if you have, for example, 1/3 to the negative first power, this is something that didn't come up. This -1 goes with both the numerator and the denominator. And we can make both of those negative exponents positive by flipping that, basically doing the reciprocal. Call it 3. Wow, I didn't teach that in the previous section. This is a very unique question. I just happened to pick up on that from the start. Sorry about that. It's kind of rough start here. Let's try this one here. 8 squared to the negative first power. That means the same as 8 to the negative second power. 1 over 8 squared, which would be 1 over 64. Okay, and so you would write this on your worksheet. You should probably do your work on a separate piece of paper so that this doesn't get all jumbled up, or there's a big empty spot on your worksheet, and you're welcome to do your work there too. Okay? All right, when you get to the bottom, again, there's big questions. Just break them apart. So like, say for example, for number 20, 2x cubed, y to the negative 8 to the negative third. There's a lot of different ways that you can do this. I'm just going to choose to distribute that -3 exponent to everything inside. You could do it a different way. That's just how I'm going to do it. So 2 to the negative third, x to the negative 9th, y to the 24th. And now, there's 2 different ways to go about it. You could say this means the same as 1 over 2 to the third, 1 over x to the 9th, and then y to the 24th, and multiply across to get y to the 24th over 2 cubed is 8, x to the 9th. You could do that. Or save yourself this middle step. This is the only one that has a positive exponent, so it's going to stay where it is. Because it's the numerator, it stays the numerator. These both have a negative exponent, so because they were in the numerator, I can flip them down to the denominator and lose the negative exponent. Or this would be y to the 24th over 8x to the 9th. Same thing, okay? This is one of those crazy things where your answer looks kind of like a math problem. And so you should be really proud of yourself. This is hard math. You can do it. I want to encourage you guys to please use your peers as a resource. Don't copy answers from your friends. That will not teach you anything. But find a friend who also did the same assignment. Compare your answers. Have a conversation about any inconsistent answers that you have, to have an educated conversation about how you came to your conclusions, and then come to the one that's correct. If you have any problems at all, do not hesitate to send me an email at drones@d231.rochelle. Wow, it's getting late. I'm getting tired. This is how you spell Rochelle. .net. Whew. Alright guys, thanks for watching. Good luck with this. Don't be bashful in getting a hold of me if you need anything at all. Thanks. See ya.